Hello and welcome to Business Analytics. This is Hari Rajagopalan and I will be your instructor for this lecture. Now you know that we have finished your z-tests with normal distribution in descriptive analytics, and the next hypothesis test is essentially we're going to look at t-tests. And t-tests, as you all know, happen when we don't have population standard deviation. So let's take a look at an example. We continue with this example of average fuel costs. It's 260 per month, and then we are looking to see if fuel costs have changed. So a researcher draws a random sample of 25 and enters the monthly costs. And let's kind of go to Excel right now, and we can calculate their descriptive statistics. So we'll go to Excel after this slide, but notice the difference between z-scores and t-scores. When we talked about average monthly fuel costs with z-scores, we actually had the standard deviation right here with this average cost. We don't have population standard deviation here, and we are going to have to use sample standard deviation to calculate standard error. So let's go to Excel and take a look at this example. So let's take a look at Excel here, and we'll just ignore all this here for the time being and just focus on the data, right? So if you look at the data here, you'll see you have 25, sample size of 25, and here's the fuel cost. So we have the population average. We can also calculate the sample average and sample standard deviation, right? So we have now the data we need to actually start working on this problem. So I'll go through all this in Excel once we go through the PowerPoint slides. I'll actually go through it through the PowerPoint slides so that it's broken up and it's easier for you to understand. So now we got the sample standard deviation, and we're going to use that to calculate standard error, which is standard deviation divided by square root of sample size, right? So the null hypothesis does not change. We are going to assume that average fuel costs has not changed. It is still 260. And it's called lack of effect or no change. And our alternate hypothesis, is saying that our sample, average fuel cost from which our sample is actually got has changed and is not 260. It's a two-tailed test. So none of this is different from what you did in the previous example, right? So sample mean we saw was 330.56, and our sample standard deviation was $154.18. And so here we go. Here we have this normal distribution, nice normal distribution. We have sample mean here. Here's the population mean. The only problem we have is that you don't have population standard deviation and you have sample standard deviation. So we can calculate our type 1 and type 2 error. I'm not going to go over this because you've already seen this when we did z-score. You can read this. And we are setting our significance level of alpha at 5%. We are willing to accept a 5% risk of deciding that fuel costs have changed when they have not. We can also use a lower significance level like 1%. But that would, when we have less alpha, it provides stronger sample evidence to be able to reject the null hypothesis. So if we can reject the null hypothesis with alpha, which is smaller, that would give us stronger evidence. But as we know, if alpha reduces, it would increase beta, which would reduce the power of the hypothesis to detect the difference that exists, right? So when we fail to reject a null hypothesis, the beta error will be larger when you reduce alpha. So let's continue with this. So we talked about the alternate hypothesis here. This is a two-tailed test, so we have to look at alpha by 2, right? We have to look at what these critical values are, and then your p-value is this area. But to calculate either the critical value or the p-value, we would need to use t-tests. So first step is to calculate the standard error. So here's the formula. Remember, now we're using sample standard deviation divided by square root of sample size, which then forces us, that gives us 30.84, which forces us to use t-scores. So here's the p-value method. Step 1, you start with sample mean, 330. Step 2, you find the t-score, which is your sample mean minus population mean divided by standard error. Do not forget, you're always dividing by standard error because the value is a sample mean. So the t-score is 2.29. And we can use this t-score to find the probability of getting less than 330. So for t-dist, you can use t.dist.rt, where RT stands for right? And you have to put in the t-score of 2.29 and degrees of freedom. So degrees of freedom is sample size minus 1, which is 24. Okay, so here we go. P-value method, we use t.dist.rt, we use 24, and we get 0.015. So p-value is 1.5%. Your alpha is 5%, so alpha by 2 is 2.5%. So p-value is less than alpha by 2. You can reject null hypothesis. And we can conclude with more than 95% confidence that average fuel costs have increased. If you want to look at it graphically, here we go. And you are essentially looking at, here's 330, right? Here is your 2.5%, and here is 0.15613%. Now remember, if alpha was 1%, this would be 0.5%, and p-value would then be greater than 0.5%, and you would then have to fail to reject the null hypothesis. Okay, so let's go here. This is the critical value method. Of course, after you have the p-value method, you're going to do the critical value method. For critical value method, you start with alpha 5%. Since it's two-tailed test, you're going to use 2.5%. And you're going to find the t-score on the right-hand side using 97.5 and on the left-hand side using 2.5. So that's 2.0638 minus 2.0638. And you're going to calculate the critical value using this formula. Your null hypothesis 260 plus minus your t-score multiplied by standard error. So the two values are 323.64 and 196.36, right? And of course, your 330 is further away, so you reject your null hypothesis. So here you can see that this value here is 323.64. This is 330, so it's in the rejection zone or the red zone. Also, if you had got a value less than 196.36, that would be rejected too. Anything in between these two values, you would have failed to reject. So let's take a look at this on Excel. Let's go back to Excel and see what we did there. So not very different in Excel. We've just set it up. Alpha is 2 by 2. We defined the alternate null hypothesis, type 1 and type 2 error. We found our standard error. We used the p-value method to get the t-score, and we used this to find the p-value. Critical value, we used this formula here, and we plugged in the values. Degrees of freedom is sample size minus 1, which is 24. And you use the upper critical level because your sample average is more than your population mean. Therefore, you use the upper critical level to reject the null hypothesis. And this should be pretty straightforward for all of you right now. Let's go back and look at an upper tail and a lower tail test. Now, we do have these values in Excel. You can go over them, but I'm just going to go over it in PowerPoint for you. All right, so we looked at a two-tailed test where your sample mean was on the right-hand side. Now we're going to look at a one-tailed upper tail test, then we look at a lower tail test, and then we look at a two-tailed test where the sample mean comes on the left-hand side. So same example, same data, but we are changing one word. We're saying instead of fuel costs have changed, we are saying it's increased. Therefore, now this becomes an upper tail test. I'm not going to read through the alternate and null hypothesis now. All of you should be comfortable with dealing with alternate and then defining your type 1 and type 2 error. remember that every problem, you're going to define what your hypothesis is, your null hypothesis, your type 1 and type 2 error. And of course, we are going to look at alpha at 5%. Let's look at the same steps here. P-value method, we're going to calculate the t-score for sample mean, which is 2.18. And we're going to use t.rt, and you're going to compare it with alpha and not alpha by 2. That's the only difference here. Critical value method, you're going to use t.inv. You're not going to use 97.5. It's 1 minus 0.05, which is 95%. So your t-score, your t inverse is 1.718. And then you're going to use the formula with just adding. You're just going to have upper critical limit, which is 311.03, which is a lot closer to the center than 330. And therefore, conclusion is we are more than 95% confidence that fuel prices have gone up. Now we're going to look at a lower tail test. Again, same example. It's just changed. We're saying fuel costs have decreased. And here's the alternate null hypothesis, type 1 and type 2 error. I am not going to go through this now. You can read it. I think all of you should be comfortable on how to do hypothesis, null hypothesis. We are going to use alpha 5% here. Now, how are we getting a sample mean of 212 and a sample standard deviation of 61.33? Well, we're going to take, let's go back to Excel, and we notice the data has changed. So let's go to Excel right now. So we are in Excel. We have a different set of data, and that gives us a different sample average. But remember here, the sample average is less than your population average. That's why we are looking at left-hand side. And let's go back to our to the PowerPoint presentation. All right. So going back to PowerPoint presentation, we calculate our t-score. It's negative 3.91. Again, t-score is sample mean minus population mean divided by the standard error. And we do the same test p-value method. Now we are not going to use t.dist.rt. RT gives the right hand side. We're just going to use t.dist, plug in the values. Here, degrees of freedom, you plug in the t-score, degrees of freedom 24, and true. T.dist gives you the left hand side. This comes to 0.0328%, which is less than 5%. Therefore, you reject the null hypothesis. And here you have the critical value method. You use t.inv. Probability here, you're going to use 5%. Remember, if it was on the right-hand side, you would use 95%. Now you're going to use 5%. Plug it into this formula to get 239.01. So when you compare 239, 239 is closer to 260 than 212. You can reject your null hypothesis. And finally, we're going to look at a hypothesis testing two-tail test when your sample mean is to the left, right? Here we are looking at fuel costs have changed from the same example rather than decreased. We are saying population mean is different, right? So here we go with this data, but sample mean is on the left-hand side, right? So now we are looking at alpha by 2. So here, if you look at this, we have the population mean, sample mean, we have standard error, but the difference is that we are going to focus on alpha by 2. So unlike the lower tail test, p-value is now compared to alpha by 2. You reject the null hypothesis because it's small. Use the same t-dist here, right? Then you calculate the t-score, degrees of freedom, put true, and then you get the p-value. And the critical value method, again, you're going to use t inverse. Remember, the probability here is alpha by 2, and degrees of freedom is 24. And you multiply it times standard error. Because it's negative, you subtract it from 260 to get 234.68. And in both cases, the answer concludes, because the sample mean is further away from the center than the critical mean, you conclude that fuel prices have decreased. And here you have the Excel file, which actually does that. And you'll notice the difference between the lower tail test and the two-tail test is one, you're comparing it to alpha by 2 here, whereas here you compare it to alpha, right? This should be alpha by 2 and not alpha. And here you use G7 is 2.5, whereas in a lower tail test, you are using 5%. So that's the only difference between lower tail and two-tail tests. In two-tail test, you're using alpha by 2. Lower tail and upper tail one-tail test, you use the full alpha value. And with this, we'll stop with t-tests.